Hello, dear students, how are you? I think you are all very fine. And in today class, we are about to study equation of motion. Equation of motion. Dear students, you know about equation of motion. What is this? Actually, when an object moving in a straight line with uniform acceleration, then it is possible that we relate the acceleration, speed, displacement and time to each other. Okay, and now we are about to do this. Okay, we have to do some derivations, okay, and derive the relation between A, V, S and T. My dear students, actually we derive the relation between A, V, S, T, or you can say equation of motion, by two methods, not only one method, by two methods. First, graphical, and second, theoretical. Okay, there is also a method that is called calculus method. Okay, but it is in higher classes, just like 11th class. Okay, in your standard, graphical and theoretical, two methods are sufficient. Okay, now let's start to derive the equation of motion. First, I want to tell you there is three main equations. First, V equals U plus AT. Second, S equals UT plus half AT square. Third, V square equals U square plus 2AS. Okay, and now I want to say to you something other is, it is called first equation of motion, it is second equation of motion, it is third equation of motion. Okay, and I want to say to you that what is V, what is U, what is A, what is T and what is S. Actually, V is the final velocity of object. U is the initial velocity of object. S is displacement. Okay, or distance covered by the object that's moving in a straight line. Okay, T, the time taken to be grow from U to V. When your velocity increases or decreases from U to V, then it is time taken, and during that it is distance covered. Okay, so time taken, and I regard it as acceleration is uniform acceleration A during motion. Okay, so now let's start beta to derive the equation of motion by graphical method. Dear students, consider the velocity time graph of a object with uniform acceleration small a undergoing the displacement s. Okay, and now I want to say to you, let u be the initial velocity of the object at timing t equal to 0. After some time, that means to say t time, the velocity will be v at timing t. Okay, now represent the vt graph of this object. I want to say to you, dear students, this is time axis, along to x axis, this is velocity axis, along to y-axis. And now, my dear students, here origin point, the timing is also 0, velocity is also 0. Okay. If I consider at timing t, velocity is u, initial velocity is u. So, at the 0 time, initial velocity is u. Okay. Now, you can write now this at point A, 0, u. Okay. After the timing t, the velocity will be v. So now consider that this is timing t. Okay. So the velocity will be v. This is written as 0 comma v, but at timing t the velocity will be v. Now represent this on the graph. It is the at t timing velocity is v. So the vt graph of the object will be, this is the vt graph of the object E. Okay. Now give the name A, B, take a perpendicular also, C, D, and it is origin point O, and now it is E. My dear students, if this is angle theta, I want to say what is velocity time equation. I want to remove this velocity time equation. Velocity time equation. Okay. Now I say to you, for the this velocity time graph, this velocity time graph, what is the velocity time graph? This is represented by line AB. This line shows the velocity time graph of the object. You know very well, acceleration of object is what? Slope of the velocity time graph. And you know, my dear student, slope of the velocity time graph is tangent of the angle formed by velocity time graph to the time axis. And you know very well, I told you, in any triangle ABC, the tan theta equals altitude upon base. My dear student, what is altitude? The front side of the acute angle, that is BC, upon base is AC. My dear students, how can we calculate the BC? Actually, BC is similar to A from the symmetricity, and AC is OD. My dear student, AE can be written as OE minus OA upon OD. Dear student, OE is V minus OA is U upon T. So now A equals V minus U upon T can be written as here AT equals V minus U. So V equals U plus AT. This is called velocity time equation. What is beta? Velocity time equation. In vector form, it can be written as V vector equals U vector plus A vector dot T. Okay, and you know anything here? V equals final velocity, U equals initial velocity, A equals acceleration, T is time. Okay beta, this is the first equation of motion. V is equal to U plus AT. Okay, now we see displacement time equation. Displacement time equation. Okay, what we say for the velocity time graph, time graph shown in this figure. Covered distance you can say, my dear student, either total displacement you can say. This is what is total displacement, anything you can say. What will be total displacement? Represented by S during velocity U to V in timing T. So what will be area enclosed between velocity time graph, VT graph, with time axis? It can also be written as area of trapezium OABD. So now also it can be written as area of trapezium, area of rectangle plus area of triangle. Area of rectangle OACD plus area of triangle ABC. Area of rectangle is OA multi OT. Plus half area of triangle means half base into height. What is BC? My dear students, OA multi OT plus half AC can be written as, from symmetricity, OD. Okay, and BC can be written as, from symmetricity, AE. My dear students, OA is U, OT is T, half OD is also T, This is OD. OA into OD. OD. OD is T. AE. AE, that's I told you, V minus U. I told you this. V minus U. Okay. Now, S equals UT half T multi V minus U from here noticed AT. So it is written as UT plus half AT square. My dear student, it is called displacement time equation or second equation of motion, where S is displacement, U is initial velocity, T is timing, A is acceleration. And in vector form you can write this: S vector is equal to U vector dot T plus half A vector T square. Now it is completed. Now we see velocity displacement equation. Velocity displacement equation. Actually, we know that total displacement is area enclosed by VT graph with time axis. So now my dear students, area enclosed by VT graph on the time axis is a trapezium. Area of trapezium O A B D. My dear students, formula is 1 by 2 sum of parallel sides of trapezium multi corresponding height. So now S equals half sum of parallel side is OA plus BD multi height is AC. Okay, my dear students, half OA is OA plus BD. From the symmetricity, the BD is OE multi AC from symmetricity can be written as OD. My dear students, OA is U plus OE is V and OD is T. Now from here half V plus U by commutative law, T equals from here T equals V minus U upon A. V minus U upon A. Okay, half A plus B, A minus B equals V square minus U square upon A. Now V square minus U square is multiplied by this 2AS, cross multiplication, and now I write here V square equals U square to go there plus 2AS. It is the third equation of motion or velocity displacement equation. Either I want to say to you, my dear students, what is that? In the vector form, V vector dot V vector equals U vector dot U vector plus 2 A vector dot S vector. It is the third equation in vector form. Now let's meet in next video. Goodbye. Take care.